All right, here we go. Welcome to the land of fairy dust, pink unicorns, and make believe. Because we're using imaginary numbers. But, oh no, imaginary numbers is something we actually use in math, so it's not fairy dust, pink unicorns, or make believe. It is actually something we use. Okay? So, an imaginary unit is the square root of -1, which equals I. In the past, you've always been told you can't take the square root of a negative number, which you can't. It's not a real number. It's an imaginary number. But even though it's an imaginary number, we're going to use it in here. Okay? So, an imaginary unit is a complex number whose square root is -1. Okay? So, I is our imaginary unit. So when you see an I, that's imaginary. That's why we don't use I as a variable. Okay? That's why we use X's and Y's and things like that. You don't normally see I's used as a variable because that means imaginary number. So an imaginary number or complex number is any number in the form of A plus BI, like 7 plus 3I. Here's the real part, here's the imaginary part. It can be just written as 5I because you can have just the imaginary part. But that's still in the form of A plus BI because it's 0 plus 5I. Okay? Complex number. And complex conjugates are when you have a complex number and then the opposite sign of a complex number. They're the same, but they have a different sign in the middle. And we use conjugates to rationalize denominators. Okay, so it gets a little complicated at times, but it'll be all right. We can handle this. Imaginary numbers. Okay. All right, here we go. Now, I is the square root of -1, so I equals I. I squared is the square root of -1 squared. What's the square root of -1 squared? But when you square root, you get what's underneath, right? So I squared is equal to a +1. That's important to know. I squared is equal to 1. I cubed is equal to I squared times I. What's I squared? 1. Oh, this is -1. Sorry, this is -1. When you square root, you get what's underneath. It's -1. So I squared is -1. I is just I. So I cubed is really equal to -I. So I is equal to I squared is equal to -1. I cubed is equal to -I. I to the fourth is equal to I squared times I squared, which is -1 times -1. What's -1 times -1? 1. I to the fifth is equal to I to the fourth times I. What's I to the fourth? 1. What's I? I. I is just I. Okay? So, I to the fifth is the same as I to the first. Why? Because I to the fourth is 1, and 1 times I is just I. So I to the fifth is the same as I. Let's look at I to the sixth. I bet it's I to the fourth times I squared, or 1 times, what's I squared? -1. I squared was -1 from right up here. Right there. So it's -1. Hey, I'm starting to see a pattern here. I and I are the same. I squared, I to the sixth are the same. I bet I to the seventh will be the same as I to the third. Because I to the seventh is I to the fourth times I to the third. I to the fourth is 1. I to the third is -I. 1 times -I is -I. Ooh, I to the third is the same. So let me make up a table to help us out. Okay, so here's our table. This is I to the first. This is I squared, I cubed, I to the fourth, I to the fifth, I to the sixth, I to the seventh, I to the eighth, I to the ninth, I to the 10th, I to the 11th, I to the 12th, I to the 13th. Do I need to keep writing? No, I don't need to keep writing because it follows the same pattern forever. Okay? Any power that's a multiple of 4 will equal 1. 1 times anything just returns it back to the original. Okay? So that's why we follow a pattern like this. So what is I to the 100th power equal to? 1. Thank you, Nathan, for being a voice of reason. Because 100 is divisible by 4. So anything divisible by any power divisible by 4 goes in this column, and it equals 1. So I to the 100th power equals 1. Now, it gets a little trickier when you have like I to the 401 power. What's that equal to? Jeez, we got some smarticusses in here. That's equal to I. And you go, how do you know that so fast? Well, I to the 401 is the same as I to the 400 times I to the 1. What's I to the 400 power? 1. 1 times I is I. Okay, see that? All right. Oh, you just don't know, Hayes. Well, that's too bad. This is Algebra 2 now. You get introduced to new stuff. There's new stuff to learn in the world. You don't know everything as a 16-year-old. Sorry. All right. So, what's the square root of negative 9? Well, it's the square root of negative 1 times the square root of 9. You just factor out the square root of negative 1. Now, what's the square root of negative 1 equal to? I. What's the square root of 9 equal to? 3. So it's 3i. Boom. All right. Whenever you see a negative inside a square root, you're going to poke out the I. So we're going to take out the square root of negative 1, and we're left with the square root of 40, right? Well, the square root of 40 can break down into the square root of 4, square root of 10. Because you take a perfect square and divide into it. What's the square root of 4? 2. So this is 2i square root of 10. That's the final answer. You split it up into the perfect square part and the non-perfect square part. Okay, C, what's the first thing you do? Poke out the I. There you go, Paisley. So it's the square root of negative 1, square root of 30. What's a perfect square that goes into the square root of 30? Perfect square numbers are 1, 4, 9, 16, 25, 36, and so on. To go into 30, which one of these multiplies in evenly? Not just is less than. Well, 25 is less than 30, so it goes into it. No, it doesn't. Any of these go into it besides 1? No. So it's just I square root of 30. 4 goes into 30? When did that happen? I've been a math teacher for 30 years, and I don't think 4 goes into 30 evenly. All right. So that is breaking down radicals with our negative. All right. Now, there's much more. Now, this is the easy stuff right here. This is even easier than the last stuff. This is just combine like terms. What's 4 plus negative 11? Negative 7. What's negative 7i plus 9i? 2i. We wrote them as a complex number. We're done. That is easy. There we go. Okay. Now, if we have a minus sign in front of this, we distribute the negative sign. What's 6 plus negative 2? 4. What's 8 plus 5i? 13i. Easy peasy lemon squeezy. Uh-oh. These aren't written as complex numbers. So, how would I rewrite the square root of negative 36? I poke out the I, so then it'd be 6i. So it's negative 4 plus 6i plus negative 2 minus 9i. And then combine like terms. Negative 4 plus negative 2 is negative 6. 6 plus negative 9 is, ta-da! All right. So when we have a minus sign in front of parentheses, distribute it. What's 3 plus 4? 7. Negative 2 plus negative 1. All right. So that was the easy stuff. Now to get a little more complicated again. Okay, here we go. This is not that hard. This is just the distributive property. Distribute. Negative 2.5 times 8. Negative 20. Armando is right. I don't know why you wouldn't trust Armando. Plus, negative 2.5 times negative 9 is a positive 22.5i. Just the distributive property there. But here, we have to do FOIL. 3 times 3 is 9. Outers is plus 6i. Inners is minus 6i. Last times last is minus 4i squared. What happens to our middle two terms? They cancel. These are called conjugates. They're the exact same thing with opposite signs in the middle. Okay? Now, this is 9 minus 4i squared. But what did I say up in my chart that I squared was equal to? So it's 9 minus 4 times negative 1, or 9 minus a negative 4, which if we go plus or positive, 13. Okay? Now, that only happens with complex conjugates that we get rid of the I part. Otherwise, ones like this, we'll keep the I, we'll have an I in the answer. So if we FOIL this one, 5 times 8 is 40. What's the outer? Plus 15I. What's the inner? Minus 16I. What's the last? Negative 6I squared. Make sure you put the squared on or you're going to screw something up. All right, so 40, 15 minus 16 is minus I. And then minus 6I squared. What's I squared? Negative 1. So minus 6I squared is actually plus 6. So it's going to be 46 minus I. What do we do on D? What do we do on D? Distribute 15I minus 12I squared. What's I squared? Negative 1 times negative 12 is actually a positive 12 plus 15I. When you write them, we write the real number first, the imaginary number second. So in that one, we had to change the order. So we get it into A plus BI order. Okay, last one. Let's FOIL this one. 3 times 7 is? Outers. 6I. Inners. 42I. Last times last. So it's 21 plus 48I minus 12. Because plus 12I squared is minus 12. So then it's 9 plus 48I. Oh, we weren't done. We got one little part left. Yep. Fractions. All right. We can't leave square roots in the denominator, so we can't leave i's in the denominator. So to get an I out of the denominator, if it's just an I, we multiply by I. But most of these won't have just i's. They'll have another number in there. So we're going to have to multiply by the conjugate of the denominator on the top and bottom. So we're going to multiply top and bottom by 2 plus I. Top, distribute, 20 plus 10I. The denominator, 2 times 2 is 4. Outers and inners in conjugates are always, always, always going to cancel. So do we have to do the outers and inners? No, not if you know they're conjugates. If they're up like this, these aren't conjugates. They're not the same things with opposite signs in the middle. These are the same things with opposite signs in the middle. They're conjugates. What's negative I times negative I times positive I? Negative I squared, which is 4 minus a negative 1, which is 4 plus 1 or 5. Can we reduce this fraction? Yeah, both these are divisible by 5, so it's 4 plus 2I. Boom, we're done. Let's look at this one. The conjugate of your denominator here is negative 1 minus 2I. So FOILing here will take a little bit. 4 times negative 1. Negative 4. Outers is minus 8I. Inners is, inners is plus 3I. Last times last is plus 6I squared. Your denominator, they're conjugates. Negative 1 times negative 1. 1. Outers and inners are going to cancel because they're conjugates. 2I times negative 2I is negative 4I squared. Okay, so in my numerator, this 6I squared is really minus 6. So negative 4 minus 6 is a negative 10. Negative 8I plus 3I is negative 5I. And your denominator, negative 4I squared is really plus 4. So 1 plus 4 is 5. Again, this can reduce to be negative 2 minus I. Because 5 goes into each. Let's do one more and call it good. What's a complex conjugate on D? 1 minus 3I. So if we FOIL the top, we get 4. First times first is 4. Outers is minus 12I. Inners is minus 4I. Last times last is plus 12I squared. Denominator, 1 times 1 is 1. Outers and inners do what? Cancel. Minus 3, 9, I squared. Now we all know that I squared equals negative 1. So 4 minus 12 is a negative 8. 12i minus 4i is negative 16i. In my denominator, 1 minus a negative 9, or 1 plus 9 is 10. What can I take out of everything? A 2. If I divide everything by 2, it's negative 4 plus a negative 8i, or negative 4 minus 8i over 5. All right. There we are. Pink unicorn assignment.